Thank you very much. Let's start. So this talk is going to be about my personal abusive relationship with AngularJS. So who here in the room knows AngularJS? That's a lot. So who here is cursed with having to deal with it, like writing code in AngularJS? Only one person. That's good. I like it. Who here has to pen test against websites that are using AngularJS? All right, that's a bit more, like more people pen test than write. Let's see. I don't think we need the introduction. That's me. I'm Mario and maintain some projects and pop some alerts. And you can follow me on Twitter if you want to, and you can write me emails if you feel like it. I might even respond. And today we're going to be talking about AngularJS. Don't be fooled, we're not going to be talking about AngularJS 2.0 because it's too early. There's nothing there yet that is like worth having a deep look at because no one uses it yet. It's too fresh. We're going to be having a look at AngularJS 1.x and how it deals with security and why this is relevant for us as testers. One question that I'm personally going to ask and try to answer is whether AngularJS is the honey boo boo of JavaScript frameworks. Who here knows honey boo boo? That is surprisingly few people. You should really have a look at who honey boo boo is because it's terrifying. Like, just like have a look. You will be surprised what kind of things exist. Anyhow, what is AngularJS? AngularJS is one of the most popular model view controller frameworks. Actually, it's called model view whatever because it's so flexible and they wanted to have something cool in the name, so they call it MVW instead of MVC, which is fairly well known. And it calls itself the superheroic framework. And you can see that there's a certain amount of self-love involved, and it is maintained and recommended by Google. So people who consider using this framework might be extra encouraged to do so because they see a big company name following the name of the framework. It has a very polarizing philosophy because it tells you certain things that you cannot do anymore. It tells you that you cannot build web applications the classic way anymore. You have to build them the way the framework wants you to do so. And if you don't, then it's going to be bad for you. And we're going to see why that is. It still has an ever-growing user base, so there's more and more users and websites adopting to this framework. And if you have a look at the traffic on the GitHub repository, you will notice that there's a lot of things going on. Tons of pull requests, tons of commits. So there's a lot of activity here, which also, in a way, makes it attractive for an attacker. Now, the question would be, why talking about AngularJS again? Because I have been talking about this before in a different presentation that was more on the general topic of JavaScript model view controller frameworks and checking how they destroy existing security assumptions or modify them in a way that is good for the attacker. Now, AngularJS is special, and it's like a match made in heaven because they have so much power in the framework and they enable developers to do so many things in so many interesting and new ways that, of course, attack vectors are being made available too. And in the very beginning of our research, that is like 3 years ago, we found some trivially to exploit bugs in AngularJS, in the olden versions, like 1.0 point something. And we wrote the developers, and they said, like, yeah, we don't really think it's a vulnerability. And we said, like, yeah, we do think it's one. And then there was a discussion, it was a bit straight. If you click this particular link here, you will be led to the Google Doc where I actually, in person, debated with the core team about whether this is a security issue or not. So full transparency, have a look at this thing. It was getting a little bit frustrating. But it's still not personal, I think, so I'm just very interested in this framework, what it can do, how it does it, and how this actually affects websites that believe to be secure, but all of a sudden they're not anymore because of this framework. So here you can see a screenshot from a search engine, and you can see what you find first when you Google for AngularJS, and it says like, yeah, we are the superheroic JavaScript framework, so they are really proud of themselves. As you can see, a lot of self-love, superheroic, and it's got a polarizing philosophy, so it changes the ways websites are working. You cannot do certain things anymore, other things you have to do to make it work. They break the API that they offer very, very, very often. So it's absolutely common for a minor release that a couple of APIs are being broken. And if you follow the changelog and just have a look at how often they broke the API in the past, you can see if you just like search for breaking, there's like 92 matches. So they broke the API like 92 freaking times. That's incredible. So you might get the feeling that they only break the API because it's fun. They do have the assumption that HTML is not capable of doing enough. They like HTML, but they think, yeah, still not enough. So there should be more power in HTML. More things should be available to developers to be done declaratively. Meaning, I have a tag, I have an attribute, I put stuff in there, and then magic happens. That sometimes happens in the HTML world. But not always, and that's why we need JavaScript. And they say like, no, this should all be handled by HTML. So we need sugar on top of HTML. We need new attributes, relations inside the HTML structures, and then magic happens. And indeed, magic does happen. With very few things, you can invoke very powerful features. So again, is AngularJS the honey boo boo of model view controller frameworks? We don't know yet. Let's check this out. They do have fairly high security standards, so it's not about bashing the framework here. The security level is indeed great if developers follow the rules. And, well, the problem is that the rules dictate that your web application cannot be like a classic web application. So this old thing where you say like, hey, I have a GET request and it has parameters and I send it to the server and then the server sends some stuff back and there's like, input is mixed with the output and with the structure. You can't do this anymore. You have to separate stuff. But who does it in the first place? Like few websites actually strictly and consequently do it. So what they, and I mean the Angular team, say on their website is essentially you can't do anything anymore that you used to do with classic websites. You cannot mix client and server-side templates. It's impossible. You can't do this. So there is no such thing as reflection anymore. You can't send a get parameter and then you get the get parameter back. Can't do it. You can also not generate templates dynamically based on user input. And you're like, why? That's an awesome feature. I'd love to do that, but you can't. Like in AngularJS, you can't do that. Templates have to be static. Of course, they are usually not, and that is where we come in as attackers, but at least the description says somewhere like, you can't do it. You should also not put user input into scope eval, like really, kind of Captain Obvious, but people do that. We see this all the time, but you shouldn't do that. And last but not least, they recommend to use CSP. And it's kind of special because they are capable, and that is one of the few frameworks where this is the case, they are capable of running on a website that is utilizing CSP. Most other frameworks can't because of internal features, but they can. They have a special mode that enables them to run on CSP-enabled websites. We're going to talk about this in a sec. You will find this thing on docs AngularJS org guide security. It's not that super easy to find, but at least they wrote it down at some place, and you get some kind of picture what they want from you and what not. But now let's be nasty into actually some attacks. And the question is, this topic is huge. AngularJS is huge. It's a huge framework. There's so many attack vectors. And it also depends on how websites are using it, what the implementations are, not only on the framework's core and so on. Depends on plugins and whatnot. So let's first structure the whole thing and find out what we actually want to attack here. Well, there's 4 nice vectors that are really sticking out. There's more, of course, but those ones are really sticking out. And we see them pretty much all the time during our tests. Vector number 1, they have a sandbox. And the sandbox is supposed to isolate expressions from the DOM. You want to attack that. Attack number 2, they have a sanitizer. So they have a piece of code that allows you to pass in a string of HTML, and what comes out is sanitized HTML that is safe to use. That's a perfect target. I love it already. Then they have a CSP mode, as mentioned, so they allow developers to use both CSP and a fancy framework, and that somehow goes together. But they also combine this with the possibility of still using inline events and their sugared markup. So that sounds interesting. We want to attack that. And last but not least, I mentioned there's a lot of traction on their GitHub, on their tracker, with pull requests, with commits, with tickets, and so on. And we kind of want to make use of that. We want to attack the code base. We want to be really nasty and see if we can smuggle something in that is nasty and they won't even notice. That would be vector number 4. So let's have a look at vector number 1, the sandbox. The sandbox is kind of a weird creature because technically the AngularJS team says like, yeah, it's not a security feature. Don't use it as a security feature. And they are right, it's not. But everybody does that, everybody assumes so, and they kind of, based on that, have to adjust the sandbox. So when we first were confronted with this thing and had the possibility to, for example, play with websites using AngularJS in very old versions, we saw that there is possibilities to abuse an expression, to actually get access to window, to the DOM, and then execute arbitrary JavaScript. And that was not the purpose. Like, an expression shouldn't do that. So they were trying to protect against that. They say clearly this is not a security sandbox. You shouldn't rely on this thing. It's only to get developers' fingers off the DOM, because they don't want developers to use the DOM because the DOM is full of crap. And what they actually want to do is say, like, developers, please use our APIs. They are a bit better and more structured, but don't use the DOM because you don't want to go there. And they're kind of right. So we had to look at this thing, and despite them saying it's not a security feature, we treated it as such, and that made sense, because later on, other people treated it as such as well, and we found tons of XSS that otherwise would not have been found. The first bypasses were, of course, trivial, because here you can see an expression starting with double curlies, terminating with double curlies, and you cannot just go there and say like alert 1. You have to do it in a more sneaky way. So inside the expression you have a scope object, and the scope object is giving you a bunch of functionality that the framework offers. Not too much, but a little bit, just the things that you need inside an expression. But every scope object or every object or everything in JavaScript usually has a constructor. And the constructor of the scope object was object, and then you ask the constructor's constructor, which gives you the function constructor, and the function constructor is equivalent to an eval, so we can throw in a string, and then you have code execution. That's exactly what we did here. It's like baby steps. So that was easy. We reported this, and they fixed it, and things were good. So if you want to play with this thing, this is like copy and paste ready. You just like copy this thing, paste it into your editor, double check it that I didn't hide anything in there, and then you execute it, and you will see an alert. I think you will even see 2 alerts because the parser was broken back then, but well, better true than none. So as mentioned, they fixed that, and they made the sandbox a bit stronger and said like, okay, this thing with the constructor, that sucks. We kind of need to prohibit access to the function constructor because function constructor is evil and gives us access to the global object from anywhere in the DOM. So we need to prohibit that and make sure that no one can use the function constructor. And they did that. Then other people had a look at this thing and found bypasses. Jan Horn, Matthias Carlsson, Gabor Molnar, Gareth Hayes, a lot of people had a look at this thing, including myself. And we all had the same goal because we wanted to get around that limitation of not being able to use the function constructor anymore, but find different ways. Here is something that Jan did. It looks complicated, but if you actually have a look at this thing step by step, it's fairly trivial. So you see the opening curlies again, closing curlies, then you see a variable assignment. We take an empty string, we take the sub method of that empty string, then we access call, and then call of the call function, then we throw something in that is trying to give us the constructor via getOnProperty descriptor and the value, and then we receive the function constructor, we throw in the alert 1, we execute the whole thing, and done, sandbox bypassed. So in this particular situation, the framework would not notice that we're actually secretly accessing the function constructor, but be fine with it, because we were accessing it via the return value of this operation here. So framework didn't notice that, so they had to fix this. Then I had a look at this thing because we were testing against a website that was using a specific minor version of AngularJS where they changed the sandbox. So before that, the sandbox was more strict with 1.2.0 than it was in 1.2.18 because developers were complaining that it's too strict. So they had to kind of follow 2 goals. On the one hand, us, annoying them constantly with new bypasses. On the other hand, developers say like, this thing is too strict now, what are you doing? So that was not a nice position they were in. I realized that in 1.2.0 we couldn't use Jan's exploit, so we couldn't just like access __proto, and then I was like, okay, when you can't access __proto, you just get prototype off and then you have the same result. So that is equivalent, and it popped the alert and everything was fine. But other than that, it's pretty much the same thing. Of course, they fixed that. Then Matthias Carlsson came and said like, yeah, what about callbacks? Callbacks are awesome. No one has a look at callbacks these days. So he took the toString property of the scope object, accessed the constructor, accessed the prototype of the constructor, and then accessed toString again, and assigning something else to it. So basically he's making sure that whenever toString or an implicit stringification happens, then it does something completely different than actually stringifying, because what it actually does is executing call. He could have even abridged it a little bit, but it was working. And he was overwriting the stringification, changing it to something else, to an actual call. Then he formed an array. In this array, he had 1 useless element, we just needed for sorting, and 1 active string that is later being executed. He sorts the whole thing, and he defines a callback function for the sort operation, which is then using toString constructor, which is overwritten here, giving us the function constructor, and we have a bypass. But of course, they fixed it. Then Gabor Molnar came and developed something similar. He basically said, okay, this whole JavaScript thing, that's too easy, and there's going to be some other way to break the sandbox. So the first sandbox bypasses that we saw were like first generation bypasses because they modify the DOM and only the DOM. This is the first second generation bypass because it modifies the internal functionality of the framework. So he has a look what he can access at in the scope object, and then he messes with the scope object, changes things, and eventually gets a free function constructor. So the first bypass that is actually modifying the framework internals itself and not the DOM anymore. So it's like generation 2. Then there was another one that was involving event interactions. Jan and me found this thing. So you basically have a piece of markup. And here you can nicely see this kind of sugaring, this kind of extending markup and the features thereof. Because you have an ng-app attribute, and then you have an ng-focus attribute that is actually defining an onFocus event. It's just called differently and processed differently, but does the very same thing. It's just an event handler. And we see that we access the $event object, then we access view, which is window, then we access location, then we access replace. The sandbox doesn't care. We throw a JavaScript URI in. We make the whole thing editable. We attach the ID of the element, which is foo, to the URL, and then it autofocuses, and then the JavaScript executes because focus event, event, view is window, location replace, and there we go. Still trivial. Well, of course, they fixed that. And then it got seemingly hard to actually attack this damn sandbox because they really put a lot of effort into this. I'm not sure how much they spent on that, but it certainly wasn't cheap. And Jan's next bypass looks like this. I'm totally not interested in explaining this thing to you right now because partly I don't understand it myself, which is okay. I don't feel bad about this, it's perfectly fine, and we don't have the time. But he does the same thing that Gabor did essentially. So he modifies the internals of the framework piece by piece, slowly, there's a little bit here, there's a little bit there. That is one of the last and the most complex second generation exploits, or the second generation sandbox bypasses. And eventually he of course gets the function constructor, he throws a string in, then that happens. So he reported, and they fixed it. So meanwhile, this thing is pretty tight. You can't have access to window, you can't have access to function, you can't have access to object because ECMAScript 5, no call, no apply, no document, no DOM nodes, nothing. Like everything is blocked in the sandbox, and apparently it looked quite secure. But was that already the end of the road? Let's have a look. Of course it was not. This is Jan's next bypass. And he basically makes, again, use of the internal stringification features, but he does two things. He attacks both the framework core and the DOM. So this is like the first generation 3 bypass, so to say, because he first says like, hey, I just take a number and then I kind of bypass the sandbox by still accessing underscore underscore proto underscore with this double index trick. Then I'm overwriting the toString method, then I'm doing some stuff here, then I call for an implicit stringification that is happening inside the eval, which is then calling the pop method that is then expecting a callback, and the callback is the function constructor, and again, we have JavaScript that is popped. I think this is actually the exploit that Nicolas was using yesterday in his presentation, and it's pretty nice. So then Gareth came and had a look at this thing. So like, all those sandbox bypasses are super complicated. Let's just like have a look at a different thing. And he was the first one to have a look at $eval. And he realized that $eval, that is always available in the scope, it's always there by default, does a certain thing because it does check for certain characters upon parsing the string. And it does so by using the char_add method. And when the char_add method would find a character that kind of implied that something bad and fishy is going on, it would say like, no, you can't do this. This looks dangerous. Don't. So he said like, okay, let's just like fucking overwrite char_add. So he takes a string, he accesses the constructor, the prototype, the char_add. He assigns array join to this. So char_add always returns true. And in addition, as a free feature, concatenates what is being passed in. This then going directly into the eval, and then the alert pops. So he reported that. And it took a long time. It took pretty much 120 days for them to fix that. And we're like, why is it taking so long? And, well, they eventually fixed it, but I had a look at the fix, and the fix was terrible. It was ridiculous. I leave it to you as an exercise to bypass this fix. I think you can do it. So you will find the slides very soon. They're already online, and it can be done. We had the bypass after about 10 minutes. And that was like very nice. And I tweeted that we have a bypass, and then someone from the core team approached me and said like, dude, you want to share this thing so we can fix it? And I said no. I hope I'm gonna have enough time in the minutes after the talk to explain why I say no and how this whole thing ended, but I think it's important. But let's wait with that for now. But the bypass is there, we have one, it's fairly easy to find, and the team is okay with us not reporting this. But more about this later. Anyhow, there's of course ways to abuse user interaction to bypass the sandbox. I had a little fetish for copy and paste for quite some time and built something that is using an ng-copy event and then modifying the content of the clipboard, and then you have something completely different in the clipboard and you put it into the DOM when you paste it, and AngularJS does the magic here, so that works as well. And I think it's still working in Chrome and in Firefox, maybe in Chrome not anymore because I think they fixed the copy and paste XSS altogether. But anyhow. So, again, the question, AngularJS, is it the honey boo-boo of JavaScript frameworks? Well, we're getting closer to the answer, I have a feeling. So let's have a look at the next thing, the sanitizer. The sanitizer basically has the purpose of accepting a string and giving back a sanitized version of that string. So no active stuff in there, no evil stuff in there, no alerts that can pop, no things that can leak accidentally. And of course we needed to have a look at this thing. It's a component and it's called $sanitize, and it's used by default in many, many situations. Whenever you map markup directly to the DOM in AngularJS, it's used implicitly. You can also use it explicitly, and it looks fairly strong. Well, only that it doesn't. Because there's two versions of it. There's one experimental version and there's one traditional version. And the traditional version is still used a lot in the wild, and that actually has its own HTML parser. When I say HTML parser, self-written, you should all go like, oh, this is a catastrophe. And yes, it is. It is basically the HTML parser that was written by RuhrSec in the year 2008. So a framework from 2016 or 2015 uses a parser that is like 8 years old or even more. That's not a good thing. It was like super unstable, crashing all the time, throwing exceptions, like horrible thing. So we had to look at this thing, and that was a bypass. So this bypass was found by me and Gareth and Hayes pretty much in parallel because we were sitting on the same research grant. And the old version of the sanitizer uses and allows SVG. So all you need is an SVG specifying a namespace and then using the use element because they didn't consider the use element to be bad. The only thing that we need to have somewhere on the website is some resource that we somehow control. MIME type doesn't matter, could be a JSON, could be a GIF, could be a PDF, could be anything, but we just need to control some of the content. Whether it renders as a document or not, doesn't really matter. Chrome will then fetch that URL, will ignore the MIME type, that should be filed as a bug by the way, and then execute what is in the SVG. If you go to this URL, you can play with this thing, open it in Chrome, just click that thing, and you will see that the filter is being bypassed. So we reported that, but there's not too much that they can do other than kind of prohibiting the use element, and they would heavily restrict the entire functionality. But what they really decided was to go for a new sanitizer, a more experimental one that is not using this dusty parser, and one that is now putting an end to SVG, because like, you know, we have it with SVG. It's like always this SVG stuff, like there's always something in there, right? So now SVG is completely forbidden. You can turn it on if you want to, but it's pretty much forbidden. So we had another look at this new thing that is now using document implementation, doesn't use a parser anymore, doesn't crash that often, so it's actually quite good. SVG is dead, so we don't have access to that technology anymore for finding bypasses. Let's have a look. Turns out that in Chrome there is an MXSS vulnerability. MXSS means we inject something, everything is fine, then the browser changes up somehow with inner HTML or something like that, and then all of a sudden it's not fine anymore. Taking a URL or an anchor, giving it an href and feeding in a URL, and that URL is fine because it's pretty much nothing but a relative URL. That is not a working JavaScript URI, that's just a relative URL. We're using Unicode whitespace here. If you just put this into the document and do nothing with it, just render it, everything will be fine. You click this thing, nothing happens. It just like sends you to the relative URI. But once you change the HTML a little bit with inner HTML or anything else, then this thing mutates because Chrome thinks in the background that it would be a cool idea to just remove Unicode whitespace. It's like, oh yeah, wait a second, if you remove and strip Unicode whitespace in front of URL handlers, then the URL that was formerly relative will become a JavaScript URI, and then pop goes the weasel. So we checked what kind of characters were affected, and this one all together, and that was the next bypass. Surprisingly, both bypasses were by Google, so they were in Chrome, and caused by a framework created by Google, so that was kind of like, interesting, but yeah, I think they should be fixed. Anyhow, getting closer to the question whether AngularJS is the honey boo boo of JavaScript frameworks or not. So both sanitizers are bypassed, and I do not know if there is fixes out there, so just recently went to the website where the fixes weren't out with a fairly modern version, so I'm not sure if too much happened on this field. Let's go to A3. A3 was, who remembers, the CSP mode. As mentioned, AngularJS can cooperate with CSP. So that means if you have a website that is using strong CSP, most of the other fancy frameworks won't work anymore, but AngularJS will. That is because it also works in Google Chrome extensions and works in packaged apps and in certain other contexts where CSP is mandatory. You have to have it, you can't get around it. And well, if you want to recommend a framework for universal use, you have to make sure that it works in CSP. We can talk about the magic that is there, why it works in CSP mode and why it doesn't need the function constructor or eval, but I don't want to kind of position this now. But if you're interested in how this works, just like chat me up later on, we can talk about this. So CSP is quite cool. And in itself, it has certain potential of killing XSS, or at least making it a bit harder. And it is mandatory in certain contexts, like Chrome extensions, packaged apps, Firefox extensions, in a way. We talked about this yesterday. So it's very interesting to see that AngularJS works in the CSP context and still has feature parity, mostly. So all those features that we saw before, the sandbox, the inline event handlers, ng something something, they still work. Which of course gives us the possibility to do interesting things, because technically then the framework bypasses CSP on its own. That means if we have a website that is CSP protected, we can't do this anymore. We can't just like inject a double quote onClick equals alert1, because then the website says like, no, that's inline JavaScript. I'm not going to let you execute that. Thanks, browser, which is good. But the only thing that we have to do instead, at least in the older versions, is not use onClick, but use AngularJS, say ng-click. And then $event, which is the raw event, then view, which is window, then alert1, and that's it. No difference, same thing. So the framework bypasses itself by re-enabling inline JavaScript. Like, holy shit, why? This doesn't make any sense at all. But they did that. So of course, we reported that, and they fixed it. We also found out that it's like extremely flexible in terms of parsing. So you can either do this, or you can do that, or you can do this, or you can do that, or you can just like throw arbitrary garbage in here because they normalize for whatever reason. You can also do that. So if you run into a blacklist, fear no longer. AngularJS got you covered. So that works nicely. But as mentioned, they fixed at least the easy code execution. Not the parsing, that is still crooked, but the easy code execution. So the good thing is that the fixes are pretty good. So they, for example, check if the object that you're dealing with in the parser at the current state is window. They say like, if that is window, you cannot proceed. You cannot go any further because it's window. Just like, nope, not gonna happen. So that's annoying. But then there was this cool Chrome bug. Again, Chrome. And in Chrome, when you have a CSP-protected website, and on the CSP-protected website you create a blob, and this blob is being filled with HTML, and then this blob is being turned into an object URL, and then you take this object URL as a blob URI and redirect to this thing, then it forgets about CSP. That result where you redirect to, that document that is being shown, doesn't have CSP anymore. The trick is well known, it's public, and I think it was even Google plussed about this themselves, so that is known. Now the point is that you're like, oh, that's kind of weird because we have to execute JavaScript. Like, why do it in the first place? Like, we have to bypass CSP to bypass CSP. No, AngularJS does it for us in combination with the Chrome bug and a nice new feature that was given to us by ECMAScript 6. This is not so nice to read, so let's just like go here and let's start reading this from the bottom to the top. Here, we built a blob. We access $event, $view, and the blob, event view blob. We throw some HTML into the blob. We give it a type that is according to our needs, text HTML of course, and now we have a blob. But now we have just like this naked blob object. We can't do anything with this because a blob needs to be instantiated with a new operator. Now you can see we're inside ng-click. So we get around the limitation of having to, infiltrate and execute JavaScript that is coming from somewhere. We just do it inside the markup inline, which is good. But we have a problem because to really create a blob, you have to say new blob to get this blob. But we can't use new because the AngularJS parser says like, no, I don't understand new. So like, so we need to create a blob, but we don't have new. That sucks. That kind of limits our attack. We had a bypass in older Firefox. They weren't really caring about the new operator, but in modern browsers, you need the new operator to create a blob. Well, thanks to ECMAScript 6, this requirement has left, and we can do it functionally. So we can say $event, $view, $event.view, .reflect. Who knows what that reflect thing is? Well, JavaScript now has a reflection API. Because why not, right? So, like that was really missing, right? It's just like I couldn't wait for the reflection API. So we have a reflection API now. And the reflection API allows us to programmatically create a blob from within a function call as an argument. So all we have to do is call reflect construct, throw the blob in without the new operator, and then we get a fresh blob. So that's cool. So we have satisfied the AngularJS parser and the browser right now. So both parties that were kind of fighting against us are now satisfied. And then the only thing that we have to do is get a reference to the URL object, call get object URL, throw the blob that we created with the reflection API into that thing, get the blob URI out, and then make an event view location replace on that blob URI, and then we have arbitrary JavaScript execution because then CSP is gone, we can do whatever the fuck we want, and then we have the website under control, despite CSP, which is nice. So that is of course very specific. And we were also thinking about like how can we be like less specific and do something really, really bad, even if there is good CSP, even if the framework is at a very, very recent level, even if the website is set up in a very good way, and the only thing that we have is an injection and the website using a content delivery network. So the first thought was, wait a second, if they use a CDN to pull AngularJS from or whatever other library, then they're likely to use the Google CDN. But the Google CDN gives us not only the modern version of the framework, but also the ancient versions of the framework. So if the website is using a new version of the framework, why can't we just like re-import an older version of the framework and then get all the nasty bugs back? We tried that and it worked. So that is all you have to do. You have a good website that has good headers, and the only mistake is that they actually whitelist ajaxgoogleapis.com. Tons of websites do that. We had a look at the headers out there, and this is not that uncommon. So they use one of the very, very recent versions of AngularJS, 1.4.9. There is no nice CSP bypass here that works out of the box. Well, there is one now, but it's harder to bypass. And then the only thing that we do is injecting into the class, injecting a new script element, importing old AngularJS, then defining the click handler or whatever handler, and that's it. You just like override the fixes with an old version and bypassed. So that was quite nice and very useful. And the good thing is that it doesn't really depend on where you inject and how you inject and when you inject. If you inject here, everything is good anyway. And if you inject further up, then it's also okay, because what the AngularJS team has is for the versions starting 1.2.15 is a collision check. But for the very old versions, they don't have a collision check. And the collision check says, like, if I find an existing AngularJS version already, I'm just going to say bye-bye. So even if you inject somewhere further up the road, before the actual AngularJS is being included, it's still okay, because the old one will always win. Either you inject it later, it will win, or you inject it earlier, and you will also win. So there is nothing to actually work on for the attacker. It just works right out of the box, which is quite useful. To be honest, we use this trick quite commonly. It's not very rare. Like the last time we used it was against the .trust domain. So they had an XSS because of that, and now they have to change the spec. Too bad. Anyhow, the Google team did something really, really awesome to make like a very clear statement about the security qualities of the sandbox and expressions. And they basically blogged about this and said, like, please, everybody, this is not a security tool. If you find an interpolation somewhere on a website, just send it to us, it counts as XSS. That's a very good statement, I really liked it. And that is the ODE that the Google team dropped on AngularJS on their own blog. It's from Eduardo, and it's pretty damn awesome. So he basically just injects some markup, grabs the event, then does a repetition over the event, extracts the view object that is then window, the sandbox doesn't notice. He calls an array reduce that is using the alert from the window method as the callback, feeds it with a parameter, and then he has full code execution. Quite beautiful. So again, we're getting closer to the answer, whether this is a good framework or not a good framework, we'll see. Because we have one thing left, and that is A4. And that is the attack of or against the code base itself. So we really wanted to be dicks with this one, because we think someone has to do it, and better us than the actual attackers. So. As mentioned, they have a lot of traction on their repo. Like, there is so many commits and so many things going on and so many pull requests, and people are like screaming and shouting, and like it's like a marketplace. Really many, many things going on. What would keep an attacker from just like sneaking into that screaming and shouting crowd and planting something nasty somewhere in the code and hoping no one would notice? So we did that to AngularJS, and it worked. I talked about this thing with Google security team in November 2014, so they knew, and they were like, yeah, this is not gonna work, you're not gonna pull this one off. So, okay, but can I please try? So, yeah, but you really have to let us know when it works, because we really wanna fix that very, very quickly. So what we needed was some situation that allowed us to do something malicious, but it looks good, and they would notice, and they would permit what we were trying to do, and add it to the code base. And this is not really a bug that you find every day. Like, this is something where a lot of stars have to be aligned to kind of make this situation happen. So either you have to be really good at phishing, or you have to have really good preconditions in the code base. So we checked the code base, and one day, and that was in October 2014, something popped my eye, and I was like, there's something strange in the sanitizer. Because the sanitizer allows and whitelists two attributes that are technically dangerous. It whitelists attribute name, attribute type. Anyone remember these? What those two fellas do? Those are from the SVG namespace, and you can use them for SVG animations and set elements to declaratively change surrounding elements, which is quite cool, because you can also then declaratively change the href of an anchor from something harmless to something nasty. And technically, they already have that bug, so they already have the XSS. And I tried this thing, it's like, oh, it doesn't work. So they kind of still kill the whitelisted attributes. Now, why is that? And I realized that they kill the whitelisted attributes because of a bug in their parser. This is the bug. You can see here, they basically take what is whitelisted, and they take what they get from the markup to sanitize. And then they compare whether what they are supposed to sanitize is existing on the whitelist or not. But what they do is, they lowercase it. And as you could see here, those attribute names are mixed case. So they would receive a mixed case piece of attribute name from the markup, and they would compare it to a lowercase version from the whitelist. And that, of course, doesn't work because there's no match anymore. And then they say, like, yeah, it is on the whitelist, but we don't really see it because of our own lowercasing. So no, let's throw this out. It's like, this bug is perfect because the only thing that we have to do now is report this as a bug, but shut up about the actual implications if they fix it. And we did that. So it took some time. I think I posted the issue in November 2014 or late November 2014, and then I played the waiting game, just like sitting there waiting, forgetting about it, receiving an email saying like, yeah, thanks for the bug, we accept this is a valid bug, we're gonna fix it soon, thank you so much. It's like, yes, nice. So I had a look at the fix and it was perfect because it gave us XSS, and it's like, sweet, how good is that? So they fixed the bug, they created an XSS, and I informed Eduardo like really quickly. So like, dude, it actually worked. So please kind of inform the involved parties to kind of get rid of this thing before it actually hits the release. And we waited a little bit, and eventually they fixed it. But this is how it looked like. So you basically have an SVG, you have an anchor. This anchor has a URL or an href that is really harmless, it's just a question mark. Then we have a circle, something big, just something to click on. And then we have an animate element. And now it's just like one of these things where you ask yourself, like, is this really necessary? Do we need this kind of feature in the browser? So you have an animate element that is using the attribute name and specifying as an href. So that means that it changes, animates the exiting href of the surrounding element. It starts at second 0 or whatever time unit we're using here, and it changes it from JavaScript alert 1 to ampersand. You're like, that doesn't make any sense. We're changing it from something evil to something good? We should be doing this the other way around, right? Because it doesn't make any sense. We're diffusing the attack, we're not creating it. Wrong. Because what is actually happening here is that we're trying to change something that is harmless from something that is evil to something that is, who knows it, invalid, because we're talking about XML here. And you can't just go ahead and take an attribute value that is only containing an ampersand because we're expecting an entity here and the entity is incomplete. So the browser goes ahead and says like, oh, I'm going to change this to the, wait a second, that is invalid. I can't. Where was I? Oh yeah, with the from. So let's change it back to from. And that's how we get the attack in. So that was quite nice. Works in Chrome, works in Firefox. There's good news because, also works in Opera. Well, there's good news because SVG 2.0 is deprecating this feature entirely. And it's going to be interesting to see when browsers actually deprecate this as well and kind of get rid of it. Let's see. We'll see. Anyhow, there was the bypass we reported, and we didn't hear anything from the AngularJS team. From Google Security, yes, but not from AngularJS team. They're like, okay, 1 week passed, 2 weeks passed. They came up with the RC1. It's like, damn it, it's getting close. They came up with the RC2, and it's like, holy shit, they're close to release. They have to fix this. So we pinged them again and again and again, and eventually they actually did fix the bug. So they completely restructured the way they fill the whitelist with like a different mapping function, and now everything is fine. So yeah. And they also added this thing to one of the core components, specifically to the $sanitize component. So like, okay, just never ever, also just don't, just like no one can touch this. Like we have enough, there's another person like this, and then please just like double review whatever, just like no. It's like cool. At least we did something, we created a comment. But not everybody liked us for that. I think these kind of things are necessary to be done by attackers who do evil things, but with good things in mind, and it's better that we do it than someone else. But not everybody liked us for that. So yeah, we even got bug bounty for that in the end, so they even gave us money. Ah, sweet, sweet money. So, let's draw a quick conclusion because I'm running out of time. We've seen 4 attack vectors now. Sandbox, Sanitizer, CSP Mode, and just attacking the people and the code themselves, but just like abusing their own bugs and turning them against them, and they won't even notice. It was a bit unfair, but now they know. I do believe that AngularJS does in fact extend the attack surface dramatically. So there are so many things that are not necessary, and I do not really think that they built this framework in a fairly responsible way. Because yes, they specify how to use this framework, but they did not put into considerations that developers are gonna screw it up anyway, somehow. Sometimes you don't even know that you screw it up because you don't even find that particular website that tells you how to do it right. You just say like, I have a website already, and it's working fine, it's perfectly safe against XSS, but I want to coolify this thing and put AngularJS on top. And that's it, then you're done. A majority of our clients actually did that, multiple times in a row. So we asked our clients, so did you really fix it? Oh no, we just upgraded the version, no, the XSS is gone. It's like, no, it's not gone. So we had so many awkward discussions with clients doing exactly that. And I think the framework should have seen it coming, and I see the framework should have had better and more prominent security information to teach developers to not shoot themselves in the foot. Because it's like a machine gun, they keep shooting themselves in the foot all the time, multiple times in a row. I do believe that Google's team, meanwhile, does actually quite well. So they have all the communication, they had this blog post where they're putting all day on themselves. I do believe that the entire team and the documentation could do a little bit better in helping developers and kind of enumerating these things and actually making the risk that you undertake or that you accept when putting AngularJS on top of your existing applications more prominent so people really understand what is going on. And yeah, I want to conclude here, and I want to kind of finalize with this one last thing that I was mentioning. So I said something when talking about sandbox bypasses in the middle of this talk, and I said that we have a bypass and that they asked us to give us the bypass so they can fix them, and we said no. And now, quite understandably, you might say, that is not a good move. Like, why did you do that? That is not very ethical. And I agree, it's not very ethical, but we have a reason for that. And we have an agreement with the maintainers of AngularJS right now. So basically, I tweeted that we have the bypass, and someone from the core team came at me and said, like, dude, do you want to share that exploit? It's like, exploit? You never called it exploit in the past. And I said, anyway, I don't want to share it. And he's like, okay, that's sad, why not? So like, I'm not going to explain this in 140 characters, let's jump on a call. He said yes. So we jumped on a call, and I was talking to Pete Bacon-Darwin, who's now the core tech lead of the remaining parts that are there with AngularJS 1.x. And he asked me right away, and said like, so what do you want? Do you want money for this thing? It's like, no, I don't want money. What our problem is, in a penetration testing firm, is that we have to deliver proof of concepts to our clients. We have one client, they have an AngularJS XSS. We point out where it is, we give them a proof of concept with a popping alert or whatever we use. Then they fix this thing by updating the version, testing the vector that we sent them. So like, it's not working anymore. So we say then, yeah, but you just updated the version. Now we have to have a new, we have to find a new sandbox bypass. That's gonna cost us time, sorry. So they again require us to have a look at the code, bypass the sandbox again, and prove to them again that it's still vulnerable. That happened like 6 times in a row. And after 6 times in a row, always finding new sandbox bypasses, that always takes you like maybe 2 hours, maybe half a day, maybe a full night. Eventually you get sick of finding sandbox bypasses just to prove to your clients that they're still vulnerable. So my line of argument to the maintainer of the AngularJS team was, we have a sandbox bypass, we don't want you to fix it, but we don't want to use it for bad. We just want to use it to prove to clients that even if they update to the latest version, they're still vulnerable, and only if they really fix it, by setting, for example, the container to engine unbindable, then they're safe. And we can't do that if we only have tools that throw there's like a console error, and the client comes to us and says like, yeah, but you can't execute arbitrary JavaScript, so we're fine, right? No, you're not, because someone else will at some point, and it's probably likely going to be us, because we now have to sit down in our free time and find a new bypass, so we finally get the client to secure their applications. Do you see the dilemma here, or do you see the general problematics? Cool. I see some people nodding. So I explained all this thing to the maintainer, and he told me over the phone, like, you know what? That's cool with me. So, okay, that was easy. So he's fine with that, they're fine with that. He basically said, as long as you don't publish this thing, you can keep it. And he also explained that 1.x was pretty much abandoned, and that there's like a couple of people left maintaining this thing, and that this is also the reason why the last sandbox bypass took so long to fix, like 120 days. And, well, this one would probably also take a long time to fix. And yeah, there is no reason to actually fix it, because the project is pretty much dead. All the energy of the core team is going into 2.0. And if you're using 1.x, be careful, because security patches are not going to come. And yeah, that concludes my talk. Thank you very much.